Hi, welcome to Maggie Teaches, and today we're going to talk about speed versus velocity. So, I have things started, got a little bit of a new setup here today. So, today, speed versus velocity. Remember, we had already talked about speed and velocity and the difference between vector and scalar quantities. So, speed is a scalar quantity, and remember that is just going to tell us the rate that we're moving. So that is the distance traveled per time. And this is scalar. So a distance per time, which is scalar. And velocity is going to give us a little bit more information because this is one of our vector quantities. So this is going to give us the speed, but it's also going to give us something more. So speed plus we're going to have our direction. And this part is what makes it that vector. So it's going to give us a more complete bit of information. And this is why we're interested in it in physics. This is what makes it more important. So velocity is our vector quantity that we're interested in. And for velocity, remember that velocity is going to be d over t. Now over here, I have some practice problems for us, but what I wanted to get going was I'm gonna put these up here when we have our practice problems now, but we're gonna have this set up as a reminder, and remember that we have our set of mechanics questions on our reference tables, and I'll put the link below. And so we have some of these already set up, and we know two of them already. We know that we have our velocity and our acceleration, but I'm gonna put them here as our reminders. So we're gonna just have this written up here so that we always know. So we know now velocity is our distance over time or displacement over time. So our first one, I picked out some good ones, I think. According to trackandfieldnews.com, the boys' 400-meter record holder for high school is Daryl Robinson from Wilson, Tacoma, Washington. And this is when I looked it up on 9/17/19. With a time of 44.69 seconds, and that was set back in 1982. What was Daryl's average velocity during the race? Now, I wanted to point out some things so that this is the way that I solve things, and this is how we'll go through each one. So when you're taking these tests, you're going to get a lot of information. So the first thing that we have here is right here, we have our distance. So let's take an inventory. We are given a D. So we keep reading. Okay, yep, Daryl did that distance. Here we have 44.69 seconds. Okay, we have a T. Wonderful. 44.69 seconds. What was Daryl's average velocity during the race? So this is what we want to find out. So our velocity is what we're trying to find. So that now we've gone through all of this information. We know the distance. We know the time. This is what we're looking for. So we always want to take our inventory first. And sometimes they're going to give you extraneous information. You're going to get a lot of this stuff. There's going to be extra information there. But what it comes down to is, what are they asking? What have they given us? And now we can go back, because you're going to see that when you look at your reference tables, we have lots and lots of information here. We have lots of things that we can look for. But so if you're really at a loss when you're taking your test, you can kind of then, using this information and what you have, go back and kind of piece it together. So here's our equation. Next step is, okay, our equation is V D over T We have our D, we have our T. Life is good. We can just plug it in. 400 meters. Make sure that you always put your units in. Over our time of 44.69 seconds. Give you a second to do that while I look to see where I did my math. Make sure that, again, we're going to be doing a lot of equations here, so we're going to make sure that we always put our units in. So we're going to substitute in with our units. And when I did my math, what I got was that when he was running, his velocity was 8.95 meters per second. So there you go. If you want to set the 400-meter record, you're going to have to travel faster than 8.95 meters per second as you run. So, the next one, a little more near and dear to my heart. You'll find this as we go along. I like racing. So, this summer, we have June of 2019, Oliver Jarvis, who was in the number 77 Team Jost, I'm not sure how you say that, who was in the IMSA DPI class, broke the track record for the fastest lap when he took the pole at Watkins Glen International. With a lap of 1 minute, 29.639 seconds. His average velocity was 61.046 meters per second. How long was the track? So there's a couple things we're going to have to do here. So first of all, we have his fastest lap when he took the pole was 1 minute. So here is our time. His average velocity, we got that. So this is our time. We have a velocity. And now we want to know how long was the track. So this is what we're looking for, distance, right? Now, this one, when you're going to go, if you're going to take the Regents here in New York State or most of the EOGs that go on, they're actually going to be two-steppers. And so this one we actually have, 1 minute and 29.639 seconds. So this is actually going to be something that you're going to have to do an extra step in. So our time here is 1 minute, 29.639 seconds. That's a little cumbersome. So the first thing that we have to do, they're expecting you obviously to know that a minute is 60 seconds. And then we have to add our 29.639 seconds. So in order to get a time that we can use, we have to add our 60 plus our 29. So we're going to get our 89.639 seconds to make it usable in our equation. So that's our first step. Now, we already have that our velocity here is our 61.046. And then our distance this time is what we're looking for. So the equation that we want to use, again, velocity equals distance over time. Now this time, I'm just going to plug it in as it is because this to me is easier, but you can rearrange it if you want to. So we have our velocity as our 61 meters per second, 046 meters per second equals our unknown, so I'm just going to leave my D in, over our time of 89. 0.639 seconds. So in order to get our distance by itself, we have to multiply on both sides by our 89.639 seconds. Keeping our units together. So we keep our seconds, and now we can get rid of these because when they multiply out, they go away. And now we're just left with our meters. So I'll give you a second or two to use your calculator to multiply those. And when I did it, you can check your math. And I'm going to round a little bit. So I got 5,472.1 meters, which is about 5.47 kilometers, which if you look at the track site, they say it's 5.43 on their website for WGI. And that is, Watkins Glen has two track configurations. So they have one that has what they call the boot, which is the long track, and that's what they do for IMSA. And so that's the longer track, and then without it is what NASCAR uses without the boot. And the NASCAR record was actually set in, I have it here, by Jeff Gordon, and it was set in 2014. And when you look at these speeds, Oliver Jarvis set his speed at 136.547 miles per hour when he got at the pole. And Jeff Gordon set his at 129.466. So just the difference in the two types of cars that they use. So a little racing geek trivia for you. So this is what we can use these equations for. So velocity equals distance over time. So I hope you're enjoying this. If you need more help, I am getting a site together so that we can do more practice problems. And as soon as I have that up, I will have that description added into all of these videos so that you can find that. Enjoy, and happy physics.